Hello, this is Narang, SSCU 380 UMass Global. Today I'm here to talk about IBM Watson and supercomputer and its capabilities. In this presentation, we'll talk about what IBM Watson is, what makes that tool is an incredible tool, incredible capability. We'll also talk about that, what are the current limitations of supercomputers, and especially when it comes to unstructured data using NLP capabilities, and any concern related to this. There's a famous quote from Thomas J. Watson, the first CEO of IBM, that all problems of the world could be settled easily if men were only willing to think. The trouble is that men will only often resort to all sorts of devices in the order, not to think, but because thinking is such a hard problem. I think at that time, J. Watson had an idea that human ability to continuous thinking sometimes becomes a hard work where basically a tool, a technology, or platform or solution need to come to solve that problem. I think that was the vision which led to take his last name and then convert that into a product which exists today, called IBM Watson. What is IBM Watson? It's basically a data analytic processor which uses NLP capabilities to translate large data into a human speech. What it does, it converts the data processing into human pose question, where basically a complex sentence can be broken down into a simple human language or a human speech. Why it matters? It matters because it processes vast amount of the data and returns answer to the question. These are the questions which a lot of companies cannot solve, but it is available in the data. It requires people to read a lot of books to find the data, which Watson can do within seconds. It leverages machine learning to process large amount of data and almost come back with an answer quickly. Now, how Watson is being used? Watson is basically being used in every vertical, starting from cybersecurity, health industry, commercial, automotive, financial, IT, everywhere. This technology is often used by any company and every company who deals with data analytics, and they care about understanding that how data can respond to their business needs. This used to be a very critical capability, but over the time, Watson has become so user-friendly that now it's even being used on a smaller scale, small business, and even consumer end. Now, talk about history of Watson. Watson all started with a small project as part of my research in 2006. World saw that first time when Jeopardy came in Feb 2011, where basically the demonstrations became a reality, what that means from a product point of view, from a vision point of view. But it didn't stop there. This was August 2011 when basically it became the commercialized product focusing on healthcare. It solved many use cases for health industry, which would have taken decades for any health experts to resolve those issues. In 2012, Watson became an expansion plan for the financial industry. And since 2012 onwards, Watson has been scaling across very cross-industry application, from health industry to finances to banking to automotive to security and so forth, so on. Now, what are the capability of Watson which differentiate it from anything else? There are three core capabilities which makes Watson unique compared to any other technology exist on this planet. The first is understanding. Watson is not just only understand information from a point of taking information and processing it. It tries to understand information in a way human do. Break down information and try to read piece by piece and then try to combine it together. Watson also does reasoning, which means it not just takes the information, it tries to basically understand the underlying idea and concept around any information, and then it tries to have hypotheses. And those hypotheses drives a lot of reasoning, taking a simple statement and converting that into a question and answer. The last and the most critical piece is that Watson never stops learning, which means every time there's a new piece of information, it takes that information through an understanding, reasoning, and learning point of view and converts that skill set to be an expertise. In a world of Watson, expertise means skills, which means every time Watson learns something, it becomes an expertise or skills for that platform. Now, when we look at this, we always wonder that if man can do the man can follow the same structure of capabilities, then why a machine are unique, why a machine are critical? What exactly machine can do which human cannot do, or other way around? That's where this whole idea comes around. What is man machine? Now, the way I see that is it is not replacing a human or a human brain, but it almost complementing or partnering with what human uh, brain can do today. Looking at this picture, human does really well balance at common sense, dilemma, moral, compassion, imagination, dreaming, abstraction, and generalization, while cognitive systems like IBM Watson are usually focusing on natural language, pattern identification, location knowledge, machine learning, eliminate bias, and endless capability. Now, looking at this picture, you can easily see that is how cognitive capabilities are building a new intelligent information on top of what human excels with. Moving forward, how Watson works. Watson basically takes a lot of information and expertise and try to build that as a foundation of the platform. Now, this information can include a lot of different data sets coming from industry, from analytics reports to social platforms, information from email, text messages, blogs, newspaper, and a lot of the data coming from public and professional systems. Continuing on that, Watson not just takes information, he basically tries to run that information through more than 50 plus underlying technology, which allows basically information to be broken down into different things. So it can be detected as how that information need to be proceed and how that information to be used. For example, if you feed a picture to Watson, it basically looking at the picture, it tried to basically build a visual insights around it. It tried to do facial detection around it. But if you feed information or a language to this Watson, it's trying to do language detection, try to understand that as, is it English, is it a French, is it a Spanish? So looking at this diagram, you can easily see that as Watson is not just one piece of technology. It tries to take any and every form of information and then try to run through this underlying technology to basically create a common sense around it. Now, how does Watson do that? Watson basically takes an unstructured data and try to analyze that through NLP. And what does that mean is basically it takes that information and starts breaking down into pieces where basically it can understand the context around what the statement is, and but also try to understand the grammar. Once that is done, then it basically try to understand the complex questions, statements, or even emotion around that, which means it try to basically evaluate all the possible meanings and determination of what is being asked. And in the last stage, it try to present answers and solutions. So based on the question, based on information available, basically it's try to basically helps to tag the information in a format where basically it can translate and provide an answer. Now, the other form of Watson is basically helping to be a decision maker. Before Watson, most of the information used to be find information in the search engine, and then you'll find some keywords back. Watson is taking that information, taking that complexity away, and almost trying to be a decision maker there. Which means it takes a question and then try to translate that to a search engine, break down that information, and come back with a statement which helps to make a decision. Watson doesn't stop there; it also does complex math combinations, which means that it can play a very complex game like chess. The other aspect of Watson is basically converting human language into data and data into human language, which means a human can talk to a machine and then machine can respond back to the human. Some of these use cases makes Watson a very incredible tools. And this is something very much any industry, any vertical is basically looking for. Now, the other use case of Watson is to prove the point that why it is incredible is basically it tries to take information and then break down into basically simple, easy questions. It takes information in terms of first name, last name, it tries to break down serial number. And then it also takes information from a serial number point of view to tag a device attached to it or a property attached to it, and then also invoice number. Once that is done, it is basically also trying to convert information to answer simple questions. As you can see in the first diagram, David Jones bought a laptop. The amount of the laptop is 104.56 and there's an invoice number. Now, these are 5 different set of information which can be broken down into basically a single piece of information, or you can almost articulate that to answer a question. The other use case, which is a little bit more complex, is Watson takes a structured and unstructured data and basically try to make an information statement out of it. And this you can see that is, where was the X born? One day from along the city view on. Now you can see in this case that it's trying to take information and trying to almost translate that into a statement which will include structured and unstructured data. Now, talking about that, where Watson stops, it never stops. The self-learning of Watson comes from the reading. You can almost imagine Watson processes a volume of text in a way that it becomes a systematic frames. It tries to basically divide information in a way which is easy to consume, easy to process in terms of subject, in terms of verbs, in terms of object. And then it tried to translate that into semantic frames, which means now that information which was processed through the books can be easily take a shape of being converted into statements and requirements. And that's how it's explained in this PowerPoint. Now, till now we talked about the benefit of Watson and how incredible tool it is, but touching the base a little bit on challenges, limitations, is Watson highly relies on the keyword matching. Although the tool has improved, but there are still some issues around which proves to be these challenges to be a reality. Now, looking at the statement, if you see on the left-hand side, there's an example where basically information has been broken down into pieces where it can do a key match. On the left-hand side, you can almost see a different illustration, a different set of a sentence, which is again broken down into basically do keyword matching. Now you can easily see in this diagram that a different set of information are being attached to a different set of tagging, which sometimes could make it easy, but sometimes it can complex the output of it. One thing I would call it out there is that if you look at the left and right, the box around 400 anniversaries. This is a syntax which was called out from the above statement. As system is trying to keyword matching it, it will try to basically take half of that information and try to match on the other side. As you see in the green box, anniversary is being matched 4 anniversaries. Although both information carries a different set of idea, keyword matching thinks that this is the same thing. And that's how it can make a complex decisions where basically the information may not be available or may not be relevant to match the word, and it will become an information which may be having a half a sentence. Continuing with what are the other challenges or limitation around this thing is that when we convert a paraphrase into NLP capability to become information which can be translated into an answer, Watson misses the intelligence of basically dividing information into objects. If you look at this example here, you will see that as the American dream, decade before Lincoln Daniel Webster spoke of government made by an answer to them. And the true example, the people becomes the answer for this. However, as if Watson reads the definition, they will not see a reference to anybody there and will say the answer is no one, which makes the right statement wrong. The other example I will talk about this thing is the Queen's English. Give a Brit a tinkle when you get into a town and you have done this. Now, in a regular sentence, this would mean that once you get to the town, pick up a phone and call me. However, the way machine reads it, it takes the information around the tinkle and then try to convert that into a meaning of a urinate, which is a completely different sentences, which basically almost prove the point that when you look at anything like Watson or machine learning, data is basically translates into what your sentiment means. What is the meaning of that translation means. Continuing on that thought process, there's a statement that when you feed bad data, you get the bad data out. Same thing happens with Watson. If the amount of information is not processed, it doesn't have all the structured information it requires, which is usually part of many unstructured data, you can almost see that the information coming out from Watson is useless. The other challenge with Watson is basically is a learning model, which means every time you need to teach a skill set to Alexa, to Watson, you have to feed information to the point where basically it can understand that what the skill set means. Few years ago, I worked on a Watson project where I realized that a typical developing a skills in a Watson takes 6 to 8 weeks for a very simple question and answer, which means I could have taken the same information, built an information mapping, broke down the data into data modeling, and almost translate that into a simple Q&A. However, that skill set, which could be scaled up to a bigger use case, was done in a lengthy way in a Watson platform. These are some of the technical limitations and issues and concern I have around Watson, which requires him to put a lot of investments and then time into the tool to teach them. But the other impact around it is the environmental. Now, given the fact Watson is processing so much amount of data, it requires a huge compute. That compute requires a power, and then power basically does an environmental impact on the carbon footprint. In this slide, you can see that as how much extensive Watson platform is, how much more data center space it requires to run a simple services. And that basically is adding a lot more to our carbon footprint today. In summary, if you need to run a Watson, you will need 10 compute racks, which is almost a half of a data center, mid to large size data center. It will require almost close to 90 kilowatt of power and then 20 ton of cooling. Now, if I try to compare that with a human brain, it's small, it can fit into the shoebox. It can run a simple meal. That means it does not require a lot of power and a lot of cooling. Plus, it can be cooled with a paper fan. If I compare that, the statement basically will put a projection out there that there's no difference between human and Watson. The only thing which makes it Watson unique is its ability to process large amount of data at the same time, which means if human is taking 2 minutes or 3 minutes to respond to a question, Watson may be able to do that within 10 or 15 seconds, given the fact its ability to process information faster than a human brain. Thank you for listening. Hope this slide covered some of the topic we wanted to discuss in terms of what is Watson, what is good about Watson, how it's being used, and some of our concerns. Thank you for listening.